everyone, my name is Miss Connolly. I started making some math videos for my students during this crazy time so they could watch my lessons all at the same time. And then I decided to make them public so we could help as many kids as possible. So please like, subscribe, and share. Let's get as many students learning as possible. If you have anything you want me to cover, you can email Connolly, C-O-N-N, oh, it's up here, O-L-L-Y, mathathome@gmail.com. It's also in the description of the YouTube channel. So if you have any questions or comments or things you need covered, then please just email me. So we're going to talk about comparing decimals today. So in 5th grade especially, we compare in order decimals and to think about decimal equivalencies. So we compare in order decimals into the thousandths place. So make sure you take a look at the last video called Equivalencies, tenths, hundredths, and thousandths, so you can think about what I'm talking about when I say equivalencies. So let's talk about whole numbers for just a quick second because we're all familiar with comparing whole numbers. So if I gave you the whole numbers 32 and 21, you would automatically know which one is bigger because you went to the tens place and you said 3 groups of 10 is greater than 2 groups of 10. You didn't even have to look at the 21, you just knew 32 is bigger, okay? So just as a reminder, you do compare whole numbers by place value. And when we are thinking about whole numbers, if I ask you to compare 32 and 39, you look at the tens place first and you see that they are equivalent to each other. 3 groups of 10 is the same as 3 groups of 10. So you go to the right. I'm backwards, so don't listen to how I'm pointing. So anyways, you would go this way and you would see that 32 is smaller than 39 because 9 groups of 1 is greater than 2 groups of 1. So once you see that you have the same amount of tens, then you would compare the next place value. So that is one reminder about whole numbers because we can use place value when we're comparing decimals, but there's 3 ways that we're going to compare decimals. One, getting used to the mirror thing. One is through the representation. So you see I have hundredths grids on the screen. 2, we're going to be thinking about fraction equivalencies. We can compare with fractions. And 3, we are going to think about place value. And we can also use decimal equivalencies while we're doing all of these things. So let's get started. So let's say we are comparing 3 tenths and 29 hundredths. So if this was whole numbers, which it's not, some people are automatically going to say 29 hundredths is greater. But we want to think about a couple things. So first, let's represent them. In this hundredths grid, in order to see tenths, I need to make 10 equal parts. So I covered this in the previous video called Equivalencies, Tenths, Hundredths, and Thousandths, where we talk about how many tenths are in each hundredth, how many hundredths are in each tenth, how many thousands are in each hundredth, how many thousands are in each tenth, and we talk about the relationship between all of them. So watch that one first. If you need to pause me and come back, that is fine. All right, so tenths. Not too great at drawing on here. So each one of these is a tenth. So I'm going to shade in 3 tenths. Now this is on a hundredths grid. So I want you thinking about how many hundredths that is. So 1, 2, 3. So I've shaded in these 3 tenths. When we're thinking about how many hundredths that is, each tenth has 10 hundredths. So I have 10, 20, 30 hundredths. So let's just keep that in mind here. What I have just given you is the equivalent decimal. 3 tenths is the same as 30 hundredths. Okay? Now let's think about 29 hundredths. I see a 2 in the tenths place, so I'm going to shade in 2 tenths, which is the same as 20 hundredths. And then I'm going to shade in 9 hundredths. Stop there. Okay? So when we think about which one, let me get rid of all this extra jazz over here. When we think about which decimal is greater, it's actually 3/10 that is greater. Okay, so let's think about how we can figure this out. One, we can look at the representation and we can clearly see that more is shaded in here. This last box was shaded in. Okay, that's one way we can discover which decimal is larger. The other thing that we can look at is making an equivalent decimal, which I did here. So once I shaded in my 3/10, I was able to think about what's equivalent to 3/10, and that's 30/100ths. So now that I've made an equivalent decimal that goes to the same place value as this one, I can compare them. 30/100ths is definitely greater than 29/100ths. Don't forget the alligator wants to chew the greater number. It's really hungry, so the teeth face the bigger number. All right, so that's a representation, and we're thinking about equivalent decimals so that we can compare. But I also said that we can talk about fractions. So let's talk about fractions over here. I had given you 3/10, and I had given you 29/100ths. Some students who like using fractions and comparing fractions might have been able to do the equivalent fraction real quick because they know that we multiply the numerator and denominator by the same number. And now they've given themselves denominators that are the same. And so then they can compare the numerators, because when we're comparing fractions, when the denominators are the same, the fraction with the greater numerator is greater. I'll be doing a conjectures video, don't you worry. So anyways, 30/100ths is greater than 29/100ths. So this is me using fractions. I use an equivalency again to help me compare the decimals. So there's another way to see that 3/10 is greater than 29/100ths. Okay? The last thing I want us to think about is place value. So with whole numbers, we did this at the beginning, and we went from left to right, thinking about place value and which one had a greater digit in each place value. So let's try that with this. In the ones place, I see they both have a 0. Okay, so going from left to right, next I'm going to go to the tenths place. This one has a 3 as a digit in the tenths place, and this one has a 2 as a digit in the tenths place. So I ask myself, what is greater, 3/10 or 2/10? And from there, I can decide that this number, 3/10, is greater than 29/100ths because I went by place value. They both had the same digit in the ones place, so I went to the tenths place and saw that the 3/10 was greater than the 2/10, so I knew that 3/10 was greater. So there is all three strategies. So let me erase, it's going to take a second. And let's bring some thousandths in here because that's always fun. So what we're going to be thinking about is place value. We can compare them based on place value. We can make a representation so that we can see which one is greater, or we can think about equivalent fractions, and we're always using equivalent decimals. When we think about decimals, we use equivalent decimals when we're adding, we use equivalent decimals when we're subtracting, especially when we're doing the standard algorithm for those two things. I'm sorry, this is like such a process to erase. All right, so let's think about two more numbers. Let's take 0 and 42/100ths, and let's compare it to, go to the thousandths place, 365. No, let's make it harder. I gotta make it harder. I'm sorry, 1 second. 465/100ths. All right, so the first thing that I want to think about is making these representations. So I see a 4 in the tenths place, and then 2 more hundredths, or I can think about this as shading in 42 of the hundredths. So watch me go. So something that students will start doing is blocking off the 42 hundredths and shading it in. And that goes a little bit faster. So there's 42 hundredths. And then over here, we want to think about what we see for hundredths because we're shading on a hundredths grid. Sorry, that doesn't really look shaded in. We're working on a hundredths grid, so I know I'm going to do 46 full hundredths. So let me block that off. 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So first I'm going to shade in my 46 hundredths to show you what that would look like. $46. And then I have 5,000ths. There are 10,000ths in 100th. So if I have 5,000ths, I'm just taking half of this next square, which is hard to think about. Maybe I'll do a video all about hundredths and thousands because it is a little tricky. So I have 465,000ths. So when we look at, I'm looking at this and I know it looks really crazy because I'm not good at shading on the computer. When we look at Miss Conley's crazy shading, I can clearly see that 465,000ths is greater than 42 hundredths. Some people might have been thinking, well, 465 is greater than 42, but we saw in the last comparison that that doesn't exactly work. So we look at our representation and we see 465 is definitely greater, 465,000ths is definitely greater than 42 hundredths. So let's talk about our other strategies though. Let's talk about place value. So if we were comparing these digits based on place value, like we did with whole numbers, we'd first look in the ones place and we see there's a 0 here and a 0 here. So far, we know we need to move on to the next place value. So then we look in the tenths place and we see a 4 in the tenths place and a 4 in the tenths place. So they have the same amount of tenths shaded in, 1, 2, 3, 4, 1, 2, 3, 4. They have 4 tenths shaded in, 40 hundredths, same thing. So then we say, I have to go even more to the right, to the next place value, and I see a 2 in the hundredths place and a 6 in the hundredths place. So at this point, if we're using place value, we can tell that that 46 hundredths is greater than 42 hundredths. So we know 465,000ths is greater than 42 hundredths. Okay, moving on to our strategy of thinking about fractions. We have 42 hundredths, and we're going to compare it to 465. I'm trying to fit it on the screen. 465 thousandths. But it is really hard to compare fractions or decimals that are this close in size when we have different denominators. So if I want to make an equivalent fraction, I know that I multiply the numerator and denominator by the same number. So to get from hundredths to thousandths, I'm going to multiply the denominator by 10. I'm going to multiply the numerator by 10. And now I'm comparing 420 thousandths to 465 thousandths. I have the same denominator, so I know that the fraction with the bigger numerator is bigger. Okay? Now, when we're thinking about equivalent fractions, that helps you write this as an equivalent decimal. So if I was writing 420 thousandths as a decimal, I'm going to write it like this. So now, if I was comparing 420 thousandths to 465 thousandths, they go extend to the same place value. So I have 420 thousandths and 465 thousandths. I can clearly tell which one is larger. When I think about making equivalent decimals, I think about extending them to the same place value so that it's easier for me to compare. So The three strategies that we went over to compare decimals were making a representation. I'm going to use this hand because I can see it. Making a representation. We compared by place value. So just like we would with whole numbers, we did it with decimals, left to right. And then we also thought about comparing them as fractions and making equivalent fractions, because that's something that we've been practicing all year. Once you make the equivalent fraction, you can then make our equivalent decimal. You can see it. Some of you might have already been thinking about doing this to compare. But when we make equivalent fractions and equivalent decimals, and for example, when we have the same denominator, or when we're thinking about both of these being in the thousandths place, then it makes it really clear which one is greater. So I hope you enjoyed. Please watch the video about equivalencies with tenths, hundredths, and thousandths, and reach out if you have any questions. Thanks. Bye.